Hello everybody, this is Mrs. Snook with section 2.2, polynomial functions of higher degrees. So in 2.1 we did quadratics. In this section we're going to look at cubics, so third degree. We'll look at quartics, which is fourth degree, and we could even get into fifth degree. Our objectives are to use the transformations to sketch the graphs of polynomial functions. So for transformations you should be thinking A, H, and K. We're going to use the leading coefficient test to determine end behavior. And we're also going to find the zeros of a polynomial function, and we can use those zeros along with the leading coefficient test as aids for sketching. So here's our first example. Our parent function is f of x equals x cubed. I'm going to give you a little xy table for that. So x, y equals x cubed, negative 2, negative 1, 0, 1, and 2. If you plug these in, you're going to get negative 8, negative 1, 0, 1, and 8. So here's what our parent function looks like. And put in my axes. This is x, this is y. And our parent function is going to look like this. So negative 2, 1, 2, 3, 4, 5, 6, 7, 8. I have a point there, a point there, a point there, a point there. 1, 2, 3, 4, 5, 6, 7, 8. A point there. And then try to sketch this as smooth as you can, a nice smooth curve. So right there, that's our parent function. Now we're going to apply some transformations. The first one is g of x equals negative x cubed. So for here, a equals negative 1, so we're going to have a vertical flip. I'm going to take each of these points and just flip them over. So that point goes there, that goes there, that one goes there, and that one goes there. So all I've done is multiplied each one of these by negative 1. 0 stays where it was. So here is negative x cubed. All right, look at the next one. That one is an x cubed plus 1. So here we have k equals 1. A is 1, so it doesn't do anything, and h is 0, so that doesn't do anything. So when k equals 1, that means we're going to shift our parent function up by 1. So now I'm going to start with the points that I did with the black. That's the parent function, and I'm going to shift each one of them up by 1. So there, 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 and there. So now here goes the h of x plus 1. X cubed plus 1. Just shift everything up by 1. The last one we're going to do is x minus 1 cubed. So here, a equals 1. H looks like negative 1 in the equation. Change the sign, and that's 1. K equals 0. So this is going to be a shift to the right one. So what I'm going to do is I'm going to erase the red and the blue lines. And right here is our axis. And this one's shifting to the right one. So I'm going to grab my red pen, shift everything to the right one. And then here's what this looks like. That's this one to the right one. Okay. Next thing we're going to do is the leading coefficient test. And so what this does is it takes the first term, and that's your leading coefficient. So let's say we have 2x squared plus 2x plus 1. Let's make this 3x plus 1. That 2, that's your leading coefficient. And then your degree is this one that's squared. And what we're looking for is the degree odd or even? And is our coefficient positive or negative? So on this one, the 2x squared plus 3x plus 1, my degree is even, and my coefficient is positive. And I come down to the chart, I'm looking for even and positive, which is this one right here. And what it says is that as you're going out to infinity in the positive direction, your graph goes up. And then as you go to infinity in the negative direction, your graph also goes up. So the easiest thing to do is to just look at the arrows on the end. Which way are they going? And for this one, they're going up and up. So I would call this up, up. The next one, where it's odd and a positive coefficient, well, this one, that's going down. And that one's going up. So down, up. Over here, even coefficient, negative. Even degree, negative coefficient. That's a down, down. Let's see, down, down. And then odd degree, negative coefficient, that's an up, down. So up, down. You do need to memorize this. So memorize this. In this chart, let's see. I have a similar chart in your book on page 102. Doesn't look exactly like this, but it has the same information. All right, now we're going to apply the leading coefficient test. We're just going to describe the end behavior of the graph. We're not graphing it, no calculator. We're just going to look at our degree and our leading coefficient. The leading coefficient is negative, so this is a negative, and our degree is odd. So when it's negative and odd, our end behavior is up, down. Check the chart, see if I got it right. Odd and negative, up, down. Okay, that's all there is to it. Now we're going to do some more practice. We're going to describe the graph, the end behavior. Our first one, our degree is even. Our coefficient, that's an invisible 1, so that's positive. So even and positive, that's up, up. B, our degree is odd. But coefficient is a positive 1, so that's positive. So that's a down, up. You just have to memorize that. Okay, the next thing we're going to use for sketching aid is the zeros of the function. And zeros is where it crosses the x-axis. And that happens where y equals 0. So the first thing to do is set your function equal to 0. We want the y to equal 0, so set it equal to 0. Next thing you're going to do is factor. So I see a GCF of x. So I'm going to pull x out, and I'm left with x squared minus x minus 2 equals 0. I can still factor. I can factor my trinomial. So 2 parentheses. I'm looking for two numbers that multiply to -2 and add to -1. So I'm going to put an x and an x. Because they have to multiply to a negative number, one's going to be plus, one's going to be minus. There's only two factors of 2, 1 and 2. So now I just got to figure out which one goes where. Well, right here I have a negative. So that means the larger factor, the 2, is going to go with negative. So 2 goes there, 1 goes there. So now I've got it factored. Last step is to set each of these factors equal to 0. And the reason is, anywhere one of your factors equals 0, because they're being multiplied, the whole function will equal 0. So, take this x, set that equal to 0. Take x plus 1, set that equal to 0. Take x minus 2, set that equal to 0. Now you just have these little tiny equations to solve, which you've been doing since like the first day of Algebra 1. X equals 0, that is solved. X plus 1 equals 0, subtract 1 from both sides, x equals negative 1. X minus 2 equals 0, add 2 to both sides, x equals 2. So here's our zeros at 0, negative 1, and positive 2. All right, let's find the real zeros of this kind. Notice we have 4 terms. When that happens, think grouping. I'm going to factor by grouping. So the first thing I need to do is set up my groups. I'm going to group my first 2 terms together, and then I'm going to group my last 2 terms together. I have an x cubed minus 4x squared in one group. My other group is negative 25x plus 100. All right, now factor a GCF out of the first group. So I'm ignoring the second group for now, just the first group. And I see I can pull out an x squared. Oh, and don't forget, set this all equal to 0. And I get an x minus 4, because I pulled an x squared out of x cubed and minus 4x squared. Now let's find the GCF of our second group. And I'm going to pull out a negative 25, because that's going to give me an x minus 4. And I did that on purpose. I chose the negative because that allows me to have x minus 4 in both of those places. That means that x minus 4 is one of your factors. If you've got it the same in both places, you're doing it right, and you've got one factor. The stuff on the outside, that's your other factor. So the x squared and the minus 25, that's your other factor. Now x squared minus 25 can also be factored. That's a difference of 2 squares. So x minus 4, x plus 5, x minus 5 equals 0. All right, that's factored. So now I just set each one of these factors as its own equation equal to 0. So x minus 4 equals 0, x plus 5 equals 0, x minus 5 equals 0. Solve each one of these. X equals 4, x equals negative 5, x equals 5. So there's our 3 zeros of this equation. All right, we're going to analyze this polynomial function. All we're going to do is we're going to find all of the zeros, and we're going to do end behavior. So find all zeros and your end behavior. All right, so first thing I'm going to do is look for a GCF. I see 2 in both of them. I see an x squared I can pull out of both of them. And I'm going to go ahead and pull out that negative. So this equal to 0, so I'm going to pull out a negative 2x squared. That leaves me with x squared minus 1 equals 0. Lo and behold, I have a difference of 2 squares. X plus 1, x minus 1 equals 0. So now, negative 2x squared equals 0, x plus 1 equals 0, x minus 1 equals 0. So here I get x equals 0, x equals negative 1, x equals 1. Actually, because of the x squared here, x equals 0 twice. So we actually have 2 of them there. All right, the other thing we wanted to do was end behavior. We have an even and a negative. So our end behavior is going to be down, down. So if I was sketching a graph of this, my graph would look something like this. I would have a 0 there, 2 zeros there, 1 0 there. It's going to come this way. It's going to kind of go through that 0, but it also needs to end going that way. So I'm going to bring it back up again and down. This is just a sketch. It gives you a general idea of what that graph is going to look like. All right, we're going to do another example where we're going to sketch a graph by hand, no calculator, just by hand. Now these are very rough sketches. They're not going to be perfect. We will get the zeros in the right place and we'll get the general shape, but it's not going to be more accurate than that. First thing I want to do is set this equal to 0. I am going to pull out an x cubed from both of these terms. So I get 3x minus 4 equals 0. X cubed equals 0. 3x minus 4 equals 0. Now I'm just going to solve each of these. X equals 0. That was x cubed, so we actually have 3 of them. And then we have 3x equals 4. X equals 4 over 3. Let's draw in our axes. Because I'm doing a 4/3, I'm going to stretch my scale. So this is going to be 1, that's going to be 2, this is -1, that's -2, that's 1, that's -1. I have 3 zeros at 0, and then I have a 0 at 4/3. So that's right there. Next thing I want to look at is the end behavior. So I have a 3x to the 4th. That means I have even and positive. So it's going to be an up, up. So I'm going to come from somewhere up here, go through this one. I'm going to come down, go back through that one, and come out up. That's just a very rough sketch of what this is going to look like. All right, now we're going to go the other way. This is our last example. We're going to start with the zeros, and we're going to write a function for it. There are many, 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 many correct solutions. I'm going to go ahead and just do probably the easiest one. So the first thing I'm going to say is y equals. I'm going to take each 0. I'm going to do x minus whatever that 0 is. So x minus a -1/2. X minus 3 and x minus 3. And the reason I'm multiplying them together is when we found the zeros, we factored, and then each one of these factors became a 0. So I got to go the other way. So I'm going to do an x minus, and I'm going to multiply them together. I don't like that 2 in front, that 1/2 there. That's going to give us some fractions, which is no fun. So I'm going to take the liberty of multiplying that by 2. That's why there's many solutions. You don't have to multiply by 2, you'll get one solution. You can multiply by any number you want. I'm choosing 2 because I want to make that 1/2 go away. So I'm going to distribute this 2. So I get 2x plus 1, x minus 3 times x minus 3. Next thing I'm going to do is I'm going to go ahead and I'm going to FOIL these two together, the 2x minus 3's, because I know that's a perfect square. And when I FOIL it, I'm going to get this, x squared minus 6x plus 9. Now I'm going to distribute my 2x plus 1. Distribute the first term, so I'm going to distribute 2x. I get 2x cubed and then distribute again to the negative 6x, so I get minus 12x squared, distributed to my last term, plus 18x. Now distribute your second term. Distribute that plus 1, so I get plus x squared, minus 6x, minus 9. Combine your like terms. 2x cubed, I have a negative 12x squared plus an x squared, so that's minus 11x squared. 18x minus 6x is 12x, and then I have a minus 9. That's my answer. All right, that's it for today's lesson. Thank you for watching, and have a great day.